And there it is, they're together for our document. And it says the size of the file found. And the next one starts at, we shoved that, we don't really need to go there anyway. So the question is, once we know it's there, what do we do with it? Now what we do is, we do an interactive scan of the archive itself. So we interactively scan Stego, and it says, okay, I found the first file, do you want to recover it? We say yes. What do you want to recover it to? Let's say recover 1.zip. Find another file, do you want to recover that? Yes. Recover 2.zip. And the program has finished. So let's see that particular file. So first one recovered. We are unable at the moment to recover the file name, so we use a generic one in case the file name is obfuscated or something like that. But the data itself is valid, and if we open that, we see that this particular file, which is a doc file, we can open it, it's a valid zip file. So this thing can be just renamed to the zip archive because that is what it is. The zip inside a zip. You can extract that data and see it later, of course. And for the second one, if we just view it, we see the MZ signature, which is default for applications, and this is a configure sample, so we're not going to extract this onto our disk, but as we can see, we can recover all data. So we can try this engine on any of the advisories we gave, and it's going to report all the information about the vulnerabilities we just disclosed. So let's try this 11. So just scan the file 11, and it says possible steganography detected as a clear text data, and it gives you an offset and the size of the data detected. So it's kind of a fuzzy area where Stego ends and where vulnerability begins, because if it's just Stego and it's affecting some software security vendors, it's a fuzzy area. You can't really declare it as a vulnerability if it's in accord to the documentation. So we were kind of struggling with some just to file them as a right thing, but we are able to detect both vulnerabilities, steganography, and corruptions with our tool. So what's important is that we have embedded not only these 15 vulnerabilities we found, we embedded 30 more we found in the process of coding this tool. However, there's no description for that because we haven't really disclosed them yet. You're just going to skip over that content and play like the archive is valid. Once we disclose this, and this is going to be this or the following month, then the tool is going to get updated and you will see what the vulnerabilities were. But it's a process. It's 30 new vulnerabilities, and since the last 15 were patched, and some of the vendors are still rolling out patches, we want to make sure that we have 30 new and not something that was a residue from the old ones. So if it was patched, it's no good. What we found is that we were doing testing in association with Aristotle, so we were using their scanners to do that. And what we found that this wasn't really a good idea, because some of the security vendors have command line tools there that haven't had their engines updated in a while. So what we did now is have our results from Aristotle and just manually verify that if that's going to affect your desktop solution. So the data in the vulnerability advisories we get now is much more accurate. And that's it for the next engine. That's it for our presentation. We come to the question part. So any questions? Come on, guys, there's got to be one question.
How come you're not able to recover the file names? Because it was clearly in there. So.
Yeah, we didn't add that part yet. It was a short coding period, and we only wanted to make the archive valid, so you can recover the data, file name, you can get that from the archive itself if you want to. But we will add that feature in a couple of weeks, sure. Anything else? Yeah?
What amount of data can you hide in these files without?
Any amount of data. If I was to hide a particular file in it, I would definitely change the uncompressed size of the file before that. And so it all adds up. And you would have absolutely no idea that there's some hidden content in it. For CAB, it even works better because CAB uses a single stream to compress all data, and if you just change the numbers of the uncompressed size, it really has no effect at all. Anything else?
The Nix engine tool. When I'm searching for data on broken drive, some kind of recovery tool,
Okay.
it doesn't matter if it is a drive or device or file. Is the way how it finds the file similar to what the Nix engine uses?
The Nix engine opens the file you provide it to. So if you provide a zip archive, it identifies that as a zip archive. If it is really a zip, it doesn't matter which extension it is. We do data checks to make sure, and then just inspect that content.
But does it expect zip archive as a zip archive or as a raw binary search?
Raw binary searches for the signature, and we identify that as either zip, RAR, gzip, or CAB, which is supported at the moment. Okay. Anything else?
What's happening if I encrypt or password protect the zip file? Does this then work? Or
Yes, yes. You get a response which says this particular file is protected by a password. You can see that in the console. That's an information we provide with the data about the file, because this is an SDK. You can embed this anywhere. That was the basic idea. But it doesn't decrypt files or anything. In the process of recovery, you really don't need to do that. You use another tool to break your password.
if I want to analyze my zip files and there are some hidden data in it, I need to decrypt it or to unprotect it first?
First, you do the recovery part, and then it creates a totally new archive with a valid header. It still stores the information about the password, so you are able to use a brute forcer to recover the password itself on the newly created but valid archive.
Even if the original one is password protected?
Yeah. It depends on how the Stego is implemented, because this particular program we showed, it embeds new data but still a zip file inside it. So when we recover that, that's another zip file. It doesn't matter. But some tools just do inject the data. They don't compress it. They just encrypt it with a random password. And you will get a detection from our tool, and it's going to say, okay, there's some data from here to here. We have no idea what it is. Go check yourself. And when you do, you can either see if that's junk data, plain text, or something that looks encrypted, and then you can apply your cryptography tools to work with that kind of stuff. But the main issue we had is just finding the data, because this is all novel, and we have absolutely no idea how prevalent this is in the wild, because nobody really checked. Yes?
I'm just trying to get this clear. So the whole idea is, so let's say someone has your tool,
Okay.
then they'll be able to find.
Hidden content, no matter what.
Okay, so the idea is, as long as you don't have that tool, no one's able to detect that it's hidden data.
As I said, it works generically, so it doesn't matter which kind of Stego tool you use to hide files, it will still be able to detect hidden data. It won't be able to tell you how it was hidden, but it will tell you from here to here there's hidden data. And you use a software engineer to check for that data and see what it is.
And I guess your question was what do security tools do with it, right? And I mean, they're then affected by the various vulnerabilities because they're reading the file as a file format, trying to figure out the versions, and may detect it or may not, depending on how you do the malformation or Stego implementation.
Yeah.
So, like for example, these vulnerabilities for our FTK product, we basically made sure that we don't fall. Sort of as we open up each of the archives, we look at it and we're like, we don't sort of fall prey to some of those types of things. So we'll explore into them. We don't say, oh, this has got this going on. It just sort of breaks into the file without sort of being like, oh, there's a header that's messed up here. Oh, there's something appended. Let's ignore it. It just breaks into it.
Yeah.
So instead of it being a detection mechanism, it's more of just get into the data.
My initial understanding was this is actually like you're proposing a technique to hide data, but you're actually proposing a tool to
Discover any kind of data. So we are not worried about any kind of steganography implication because we can generically detect anything. So that's what we try to do. And from the software security standpoint, it really doesn't matter what kind of data is hidden, because if the user doesn't know about it, he cannot be infected, of course. Yes?